So what we're gonna talk about today are two things, debugging and testing. And so I'm gonna start with debugging, and then I'm gonna switch over to testing tools. In terms of the debugging, we're gonna look at a couple of tools that we currently have at our disposal. And these are the tools that are part of the SDK. So you guys all have them, they're free, and they're just already there. So Logcat is one of them, Debug is another one, Traceview is another one, and then HierarchyViewer. So that's roughly what we're going to talk about. So how many of you used Logcat before? All right, most of you. All right, that's what I thought. So Logcat is probably the single most useful tool. It universally works. I'll really quickly just bring it up on in my Eclipse. So if this is basically the graphical version of Logcat that shows as part of the Eclipse basically Android development tools. Now it's pretty easy to use it in Eclipse. You can basically change the severity level. You can filter it out and so on. Anybody use this tool command line? You use it command line, okay, a couple of you. All right, so I tend to prefer to use it on command line. Let me just kind of really quickly show you what I mean by that. So if I do ADB Logcat, I get everything here. And I like it this way because it's much more agile for me. I can see the results right away. But what is not obvious in a command line is how to filter the results, right? So if you look at the documentation, it's going to tell you that, let me pick what we want to filter for. I'm going to pick something here that is relatively interesting to us. For example, I'll pick Yamba app. That's my application. So if I wanted to filter based on Yamba on this tag, the documentation says you can basically do the tag column and then the severity, like debug, for example. Or you can say, I want all the severity. I want to track the tags for all of the above. So according to documentation, this should work. But as you can see, I still have very high noise to signal ratio. I'm still getting all the junk that I may not be interested in. So what they don't tell you is that you also have to tell ADB Logcat what you don't want to know, right? So to do that, you basically say all the other tags silence, right? So that's kind of one little trick, and this gives me a pretty good signal to noise ratio. So it's basically just the things that I care about. Okay. So that's Logcat in a nutshell. It's pretty useful. Well, another thing that I wanted to point out, the logging mechanism in Android is actually written as a native library. So it's part of the kernel space. And as such, it's available to all the parts of the Android. So basically, C code is using the same capability for logging as well as Java code. So that makes it basically all-encompassing, and which is very cool. Cool. So that's Logcat, and I would expect most of you to know it. The debugger, anybody uses the debugger that comes with Android? Okay. So it's there. It's available to all of you. You can basically just add the perspective for debug there, and that will switch to debug perspective. It works just like you would expect it to work, just like any other debugger. There's nothing really too new about it. You set the breakpoints, you look at the variables, you step through your code. So I'm going to fast forward through that. Traceview, anybody use Traceview? All right, so that's what I thought. So Traceview is a really useful tool for profiling your code, right? So you have an application and it just, in certain cases, appears to run sluggishly, and you don't know why, right? So let me show you really quickly how to use this tool. So I have this demo application that I've been using. It's actually the one that I use for my, my book as well. So it's called Yamba. It stands for Yet Another Microblogging App. And essentially what it is, it's a Twitter app. So let me show you. So there's my app. I'm gonna start it. And one of the capabilities of this app is that I can basically click on here and I can post something to Twitter or to our private service. I can say, hello, afternoon session. Okay, click on update, and I probably mistyped this, and it's not me typing slow, it's just the emulator. So this is ultimately gonna end up in the on the website, spelled the way it is. And so we're going to see that shortly. It takes some time to post. But essentially, we have this site here that is going to show us that once it's done.
But the emulator in Windows is not so slow as it is.
Emulator in Windows. It's mine. So the new emulator actually has the support for GPU acceleration. Mine doesn't. And keep in mind that I'm doing a whole bunch of stuff on my computer right now, including screencasting. So all that adds to the slowness. So we would see it eventually here once it's done loading. We also have oh, I'm on the wrong network altogether. So that would be a problem, because if I don't have a network connection, it's not going to go through. So let's do this again. Okay, so this probably did not work out. Noon. Because I was on a network that would not allow for connection in the first place. So this is posting, posting, posting. And it's going to tell us via a toast it's either a success or failure when it's all said and done. So we'll see that shortly. So all along, what I'm curious about is why things are running slow, right? Was this my code? Was it the network? Was it something else? I don't really know. I can speculate, but I don't really know until I can measure it. So I am going to just leave this. It doesn't really matter if it worked or not. I'm more concerned about the speed. So let me show you the code. What I'm doing in this case is, so the code for this is it's a Yamba application, which is available, by the way. Later on, I'll tell you where it is in GitHub, if anybody cares about it. But essentially, when I'm posting, I'm running this activity. And what I'm doing here is two things. Right in onCreate, I am starting to trace the execution. So this is the very first time I can actually start doing something. It's right in onCreate. It's right after we call the super. So I'm starting to trace everything that goes on in my code. I refer to this as a point A. You got to have some place you start recording. But you also have to have the point B, because you're capturing the data between those 2 points. So the point B, in my case, is right here. And I basically put it in on stop. And the reason why I put it in on stop is because I can cause on stop. I can simply leave the screen, and I know that's going to happen, right? So basically, point A here, right, in onCreate, and then point B is in onStop, and everything between these 2 points, which is a lot, I'm capturing, right? So whatever I capture is going to be stored in this file, yamba.trace. So let's take a look at this file. So this file is located at in DDMS, so it's going to be in our SD card, and there it is. So this is the file that I just recorded that a couple of minutes ago. It's called yamba.trace. So I'm going to pull this file. I'm going to dump it just on my desktop, and fail the pull. All right, let's see why ADB devices. Okay, ADB. So I'm going to CD desktop. ADB pull SD card yamba.trace right. So why is it failing to pull? Let's find out. So this should be pulling that file, and it says it pulled, right? So now I presumably have that file locally. So what I'm going to do is I'm going to start the tool called Traceview, and I'm going to specify that file. Now, so again, this is a tool that ships with SDK. So you guys have it. It's available to all of you. So this is now launching the tool. And it does take a little while to start, but here it is. So this tool is basically telling me what happened between the point A on the timeline and point B. Collectively, the entire point A, point B distance is 95 seconds. That's what it says right here, right? Here, what you're seeing is you're seeing all the threads that you have going on, that you're capable of capturing because of the process that you're running in. Now, there's certain ones that are more significant than others. Main is your main thread. It's your UI thread. It's the thread that by default everything runs on, right? I happen to have an async task, which is what I'm using to post to Twitter, which is what you should be using because you don't know how long it's going to take. And there are a couple of finalizers and the garbage collector and the binder threads, but those are more or less outside of my control. So I'm really mostly concerned about the main and the async task. And that's where the majority of the work is. So what you can do now is you can zoom in on certain parts. Like, for example, you can see that there's a little blimp in here. I don't really know what that is. But what I can do is I can select this and zoom in. And then I can click on that, right? And that tells me that this is a call to restore to count, and it's doing a bunch of graphics, and that single call took 1.4 seconds, and made so many calls and 0 recursive calls, etc., right? So you can kind of click through these kinds of things. You can double click on the timeline and zoom out, and you can kind of try to identify certain things. So this is the finalizer process ran here, and it was doing VM thread.sleep. So it did that for some amount of time, etc., etc. So you can kind of like keep on zooming in and finding the potential bottlenecks like this. Again, this is just a tool, so this is the science part. Figuring out what's going wrong with your code is the art part. And but at least this is good to know that there's a tool that can help you visualize what's going on, and you can see the execution of those things. So sometimes the problems are very obvious. In this case, it seems like it's just the network, so it wasn't like something that was taking a while to execute. So that's a very useful tool, Traceview. The next tool that we have on our list of tools is HierarchyViewer. Anybody use that one? No? Okay, so yet another case where the tool ships with the SDK. So you guys all have it. So what the HierarchyViewer does is, let me bring up my, my example app. HierarchyViewer is capable of loading the hierarchy of your screen that's going on at this moment, right? So I'm going to launch HierarchyViewer, and it's going to take a little while. So it identified all the processes. This is the one that's currently running, or it's in focus. I'm going to say load the view. So this is now going to analyze what's going on my screen. And it's going to give us a little bit more details about that. So this is my screen. I have a fairly simple screen. You can actually see my screen here, right? So this is the structure of that screen, right? Where I have a piece of text here, a button, and a big text area, right? So that's my screen. So you can kind of see it here. This is the big text area, the counter, and the button, right? And you can also, you can double click on this. Like if I want to double click on that, and you can see that this is my button update, right? That's so interesting. But what's more interesting is the structure. You can kind of analyze the structure of your UI, right? And again, this is a tool that allows you to figure out the art part of optimizing your UI. It tends to be that UI is where you get most bang for the buck optimizing it, at least in Android. That's usually the case, right? So there's actually a great talk by Romain Guy, the guy who wrote the home screen and this tool. It's called Turbocharge Your UI, and it was a 2009 I/O. But one of the things that he says is, look, you don't want this to be super deep. You want it to be shallow. You want it to be like, flat structure. You don't want too many objects. You want to be able to reuse your objects, etc., etc. So you can kind of use this tool to identify what are the things that potentially could be optimized, right? Where can you use relative layout as opposed to linear layout within linear layout within linear layout, for instance, right? Especially if you're doing that in a list, right? So that's basically how you use this tool. Secondly, you can also look at the little dots, the little traffic lights, right? There are 3 of them, and each means something, and I forget exactly what. It's like a load time, memory, amount of memory, etc. But basically, red means bad, green means good, right? So you would want to look at items like this. So this is my Yamba status update title, and there's something that I am not doing so well about that. So I can kind of zoom out. I can also analyze the properties of that particular item. So you guys know when you're setting up your UI, you get to specify the width and the height, and there are a gazillion other properties that you can put on a button or a piece of text and so on. But you only fill out a handful, 2, 3, 4, 5 properties. Well, it doesn't mean that the rest of the properties are not there. They are. They're set at runtime. So if you wanted to, for example, find out what they are, you can figure out all those details here. The measures, the width and the height, and the total length, and things of that nature, right? And this is not just for your screen, but for example, if I wanted to analyze how some other application was written, I can go to the home screen of the, for example, home screen. If I do that, I can analyze now the application of the home screen and how they wrote it. So I can learn a little bit about their design process and so on. Again, this is a much more complex piece of UI, so it's going to take a little bit of time to load up. But in a nutshell, does the tool make sense? So it's a tool for basically analyzing the structure of UI at runtime. So such it can be very useful in analyzing it, in figuring it out. So while that's loading, just to kind of summarize the couple of things that we talked about. So we talked about the Logcat, Debugger, Traceview, and HierarchyViewer. So those are the tools that you already have as standard part of the SDK. And next we're going to talk about testing. And let me see if this is loaded. So it hasn't loaded yet. All right, so moving on, in terms of testing, I'm going to talk about a couple of things. I'm going to talk about the Android's JUnit test framework. I'm going to talk about Monkey Runner and Monkey, and maybe mention some other tools. That's about it, right? So first of all, anybody use JUnit on Android, with Android? One? Anybody else? No? All right, anybody use JUnit in general? Okay, many of you. So you're familiar with what the structure of a unit test case is, right? So Android basically Android borrowed from JUnit. JUnit is a unit test framework designed by Ken Beck and originally for Java, but since then it's been propagated in pretty much every language. So there's PHP unit and HTML unit, and any unit on the planet is pretty much there. So it's a unit test framework, which means that it's for doing unit tests on your code, which means that it's a white box white box testing. So you can see your code, you can test your code. It's what the developer does to test his or her own code. So the idea is that basically you have test cases. So what's interesting about Android is just the fact that our tests are running in a container. So it's not just like I'm testing a library. Hey, here's a piece of code, and I write a little main program that drives it and tests it. You can't really just do that in Android because your code lives inside of a container. It's managed. There's a life cycle, all these other things that need to be present. So it adds a level of complexity, right? So so basically in Android we have a process that runs our application, right? So that's this application package that we want to test. So what we do is we use something called instrumentation test runner. It's a tool that allows us to test other code, right? So basically instrumentation test runner is the runner that's going to run our tests against the code that we're testing, right? So you're going to feed to it a test package. Now, test package is basically a JUnit test. So it's basically a whole bunch of test cases, right, which are based on instrumentation in JUnit. Okay. In addition to that, you may need mock objects. So what are mock objects? Well, Android is expecting certain ecosystem for the test to run in, right? So for example, you need a context, right? You may need a content resolver. You may need certain other things that are normally there in a live ecosystem. But if you're setting up a test case, you need to mock them up, right? So that's basically what that is. And later on, you can automate some of these by using something called a monkey runner. So that's in a nutshell what the Android test framework is. And I know there's a lot of text here. I don't expect you to read it. The slides are available on maracana.com. So you have all that. So don't, for later reference. So basically, what you do is you create a test project. So you have your code, you have your app, Hello World, or whatever your app is, my Yamba app. And I will then create a second app that is testing that app. That second app is also going to be an APK. So it's going to be an Android app. It's going to use instrumentation test runner, as we mentioned earlier. And usually, if your app is in a my domain, my app, the test code would be in my domain, my app.test. So basically, that's kind of the usual naming convention. So just like in standard JUnit, you basically have JUnit framework test case, right? So that's your base class for every single test case. So every single test case is a subclass of that, right? In Android, we basically have Android test case that we are using as a base class for everything. Now, when it comes to testing specific components, so remember the main components we have: activities, services, providers, and receivers, right? They all live in their own specific kind of ecosystem, a container. So we need special test cases to test those guys. So that's why we have activity test case. It used to be activity test case, but they weren't happy with it, so they created a new one called test case 2. So much for creativity in naming. So just use test case 2. Don't use the regular one because it's obsolete. So they basically have the couple of them for activities. So activity instrumentation test case. This is if you're only going to launch it once. Activity unit test case. This is a standard one. And then you have single launch activity test case. That's if you have an application with just a single activity. There's a service test case, provider test case, and application test case. So these are sort of the parent, the classes that you would subclass to test any of those specific activity services or providers or application. So in standard JUnit, you write a test case code by writing a whole bunch of asserts. You're asserting that something is either true or false or equal or matches one of those asserts. An assert is a binary yes or no. It either worked out or it didn't. If it didn't, you basically get an error, right? If it did work out, the test case passed, right? So Android does provide all the standard JUnit assertions, right? So they're there by default. So everything that you're used to from before, it's there. In addition to that, Android adds a whole bunch of new asserts. And these are things that are not generic to just any other Java application. So basically, that's why we have things like, does the group contain something? Is something on a screen? Is it visible on the screen? Is it off screen above? Or is it off screen below? So these are things that are specific to Android views, right? You want to, for example, verify that the button is visible or is not visible, that sort of thing, right? So those are some specialized asserts. In addition to that, we mentioned the mock object. So I basically said, look, your application is running inside of an alive ecosystem. So it expects certain things. It expects to have the application object. Well, if it doesn't, you may want to mock it, right? It expects a content provider. It expects content resolver, a context within which it's running. Dialog interface, package manager, et cetera, et cetera. So this allows you to basically mock or fake certain things that would normally be there in case of an application. Okay. So how do you create this? How do you create a test project? You basically, in Eclipse, you create another project, just like you would have normally created, but you basically specify that it's a test project. Okay. And so basically, we would have two projects. One would be testing the other project. So one is the regular app. The other one is a test app that's testing the first app. I'll walk you through this shortly. So next, your test code needs to basically use the Android test runner. It needs to specify that it's using a third-party library, Android test runner. Okay. And then it needs to also specify the instrumentation information. It needs to say, hey, I'm instrumenting some other application. Okay. So basically, then what you would do is you would implement the either activity test case 2 or unit test case or single activity launch. You would use one of those test cases. You would write test cases that you would want to verify that they're passing or failing. So your test case may look like this. So this is an activity test, right? So we're extending test case 2 around our activity that we're testing, right? And then in the constructor, we're initializing it with the code that we're going to test. Okay. Now, all this may sound a little bit esoteric at this level. Let me switch to the code. Oh, by the way, did this ever load? Yeah, so this is the structure of the hello of the home screen that I promised you. It's much more complex, right? And you can like zoom, double click on things and find out what it is and so on. But I think I'm going to close it. So there are many objects, but you can see how it's a pretty flat structure, right? So back to this. So let me show you a piece of code because I think things make a little more sense when they're alive and running. So I have this super simple app. It's called Currency Converter. And guess what it does? It converts currencies. So we're going to launch it. Should be launching soon. There it is. So basically, you can specify some number. So for example, 100. And I can say I want to convert from US dollars to Canadian dollars, right? And I click on convert. Now this is actually going to the cloud and it's getting the information straight from Google current, whatever exchange rates. So this should be the actual conversion rate at this point in time, right? So 102, 88899 and so on. So I can copy this number to a clipboard. I could go back here. I don't have a paste button, but at least we can verify that that's there. So that's basically what this does, right? As an application, you can change the types of currencies, etc. So I want to verify that this works. I want to automatically test that this works. So I have this code, the currency converter. What's interesting about it is the UI, right? So that's because that's what we're going to be testing. So I have a UI. Each element of the UI that I care about has a ID. So ID. So this is the initial currency that we're converting from. This is US dollars, Canadian dollars, right? I have the input somewhere, so that I'm filling in and so on, right? So I have the input clear. So this is the buttons, etc., etc. So the point is they got the IDs. Now here's the code that's going to drive the testing of this code, right? So well, first of all, let me show you the manifest file. So this is the project that's going to be testing this other project, right? So notice that I have the instrumentation specified here. Well, first, notice that we have uses library. So we're specifying that we're using a specific library for testing, the test runner. This is pretty much standard, copy-pasted in your code. Then we're saying that we're going to use the Android instrumentation test runner, and we're specifying the target package. So this is going to change depending on what you're testing, right? So that's basically what that does. So now that I have that set up, I can write my activity test. So this is now the test code that's testing my activity. So it's going to test this guy, right? So currency converter activity test is testing currency converter activity, right? And because of that, it's an activity instrumentation test case 2, and I'm specifying that we're testing currency converter. Okay. Now, all the UI fields that I found in this XML file that I care about, and again, even if you didn't have the code, you can find them out using the HierarchyViewer, right? Because you can see them. I am creating an instance variable for here. Then I'm creating an instance of the converter test, the constructor here, and I'm wrapping it around the class that I'm testing. Okay. So now, just like in any other unit test case, you have the setup and tear down functions, methods, right? So you usually want to, usually when you're doing a test case, there's certain things you need to set up Like maybe it's a database connection or pre-populated data or something like that, right? And then you have a teardown because you want to reverse back to the original 0 state, right? So what we're doing here is we're basically saying load activity. So we're loading the activity. And that's where I'm getting the original activity that I'm testing. And then from that activity, I'm actually getting all the various UI elements that I want to poke around, right? So that's my setup. Now when I'm done setting up, I can basically go ahead and write any number of these tests. So this is one test, this is another test, etc., etc. Or they all start with a test, blah, right? So this test is testing preconditions. You basically have a very simple bunch of assert not null. So these are the standard asserts. They're basically just testing, hey, that field that we got from UI, is it existing, right? And so on and so on. So we would expect all these to basically pass, right? So then we have a is it visible? Now this is not a standard assert, but this is Android specific assert. It's asserting that view that some view is on the screen. So we're saying assert on screen. You know, this would be the parent, and then this would be the view itself. Okay. Next, I'm testing the conversion from one currency to another. So I'm selecting a currency. It's equivalent of you clicking on a radio button in the pull-down list. Then I'm so selecting currency 1, selecting currency 2, typing in some text, set text. This is actually as if you entered some number, right? Then what we do is we shut down the activity, and then we restart it. Well, and then we just check, hey, did it remember its state? It should have, right? So that's basically what this test does. This test is testing the copy of the result, so it's using the clipboard. A couple of things that are interesting here is the send keys. So send keys sends the keys. It's equivalent of you typing something on a keyboard and sending those keys to a UI. So basically scripting that. Then we are testing conversion. So I'm actually sending the keys and doing all that, but I'm actually verifying that the number that we are getting is about the number that we should be getting given what we expect the conversion to be at. Reverse currency test, and so on and so on. So that's basically a whole bunch of test cases that we have written, right? So this is the code. This is our set of tests that's testing the original activity. So that's basically that, making activity lifecycle. You can test the lifecycle of activities by calling on pause, on stop, on restart. We saw that in this case where we basically did finish on the activity. Where was that?
Example of it.
Up.
Next one.
Yeah, so we're thank you. So we're testing like lifecycle events. There are a whole bunch you can do on pause, on start, on restart, etc. Setup and tear down we talked about. There is one thing that I wanted to mention, and that's turning off the touch mode. So basically, if you want to be able to send keys, in other words, programmatically appear as if you're typing in the buttons, you need to disable the touch mode so that the user is, because this is actually going to be running on a device. Okay. So that the user is not doing that. And we are actually doing that here. We are doing it right here. We're saying set touch mode false. So that we can then programmatically influence the touches by saying something like send key event, right? So send keys, for example. Key 6, 7, 8, etc. So generating touch events, you can generate on click, drag quarter screen down, drag quarter screen up, long press, scroll, etc., etc. So you can mock a lot of user, events, right? Touch events. You can send keys. It could be D-pad keys. It could be number keys. There are a whole bunch of different keys that are predefined. I'll get back to this testing on a UI thread. Let me show you first how this runs. So now we have. So basically, this is the app that just runs. This is the app that's testing that app. If I want to run this app, I would say run as, and then you would choose Android JUnit test, not JUnit test, but Android JUnit test. Okay, so I'm going to choose this. Now I want you to watch two things. So thing number one that's going to happen is this is going to be running here, right? So you're going to be seeing that. Thing number two is we're going to have something pop up here, which is actually going to show us what's going on. Okay, so I'm going to click on that so you can see that, and I'm going to open this up. So what's going on right now is we have a scripted automated test. I'm not touching this, right? So it's whatever we scripted is at 1, 2, 3. That's what's going on, and we're seeing the results real time here. So our first test conversion failed for some reason, and we have an error. So we can explore that later. Our second test, copy passed. Our third test preconditions, is working out fine, and so on and so on. So this is our final report. We basically know that we had one error, not a failure. So it's not that the assert failed, but we had an error that basically said invalid double. So something passed. So test conversion. So we passed a empty text for a double, and that raised an exception somewhere. So we have 6 tests, 1 error, 0 failures. That's basically the result of this. So when you're testing UI, there are certain specific things that you need to worry about. For one, you guys probably know that UI runs on UI thread. And you probably know that you're not allowed to touch UI from a non-UI thread. Well, we have a separate application, separate process testing our code. So obviously there are not only different processes, but different threads as well, right? So if you're just reading some piece of text, it's okay. You can get away with not doing it on a UI thread. But if you're modifying it, you actually have to do it on a UI thread. And Android provides for a couple of useful ways to do that. One is to basically specify an annotation at UI thread test. And that basically says, run this entire test on a UI thread. The second way is to basically say activity run on UI thread, and then give it a runnable that's going to run on that UI thread. Okay? So I believe we have the first case somewhere here. See this test? We actually specify run on UI thread. So that was the annotation that made it run on the UI thread. And I don't think that we had any other anything running on the other thread, but we could have. Actually, we do. So make selection is actually running. It's just running this this piece of code on the UI thread. So we're basically passing a runnable to activity, and we're saying run on UI thread. So that's something that you need to worry about when you're dealing with that. So running tests on Eclipse, that's what you guys just saw, right? In addition to that, you can actually run tests on command line as well. So for example, if you may want to script this, right? Maybe your organization runs the battery of unit tests every night, when you leave the office, so that you make sure that nothing's broken from that day's work, right? So you could basically do something like specify that you're running, I can basically say, I want to run that. I need to specify the test package name, right? So the test package name that I'm running, and the name of the class that I'm going to be using for running. So the test package name that we're running in this case is going to be this one. So I'm going to copy that, right? Bam. And the name of the class that I'm running is going to be the standard one. So it's kind of like a long line. I totally get it, but it's so this should actually run the same test. So now it's happening outside of Eclipse. In other words, you can script it, put in a shell script, have it run automatically, and so on. And you get the report, and you can then have that report emailed to you or your boss, or maybe not your boss, but somebody like that, right? So that's basically the idea with the unit testing. Again, it's white box testing, and you have the access to the source code, right? Those are the assumptions about it. So 6 tests took 35 minutes. Bam, there's your results, right? Moving on, you can test services, very similar way. There's a service test case, content provider test case, application test case. I'm not going to go into the details of that, but you'll get this document and you have it all spelled out. I wanted to mention a couple of other tools that are available to you for testing. One is Monkey. Anybody use Monkey before? Okay. So Monkey Monkey is very simple. It works like this. You basically say ADB shell monkey, and you give it some number, which is the number of seconds or milliseconds more precisely. And here's what happens. Oops. Come on. Okay, I have a monkey spelling. So this simulates you giving a phone to a monkey for 3,000 milliseconds. That's it. It's basically, you don't know what's going to happen. It's just a pseudo-random number of events. You know, it may change your language to some language that you can't pronounce. It may make long-distance phone calls and send SMSs. So be careful when you execute this on a real device, right? And usually don't expect to get the device in any usable state afterwards, right? So it can totally mess it up and put, you know, for one, puts it in a language that you don't understand. But it's a totally random kind of thing. Why would you want to, and sometimes the monkey gets stuck because it enters an application and doesn't know how to get out of it. So then you get reports like that. Oh, okay, it opened my camera. So this is exactly the type of thing you don't necessarily want to have. Yeah. So this is a tool that was, I believe it was initially developed for carriers to do stress testing on a device. You can specify, for example, if you just want to test your app, you could say -p, and you can say com.maracana.android.yamba, for example, and that's only going to test your specific package, right? It's pseudo-random, which means that once you get the application to crash, you can use the same random seed, and you can have the crash reoccur, right? So that way, you know, until you fix your code, yes. So this is somewhat useful, right? It's fun to watch the monkey play with it, but that's about it. Now, so that's one tool. It has a little bit of a use. We documented that here, and there's some options for you to control it. But other than that, it's so-so, right? It's more, like I said, for carriers. Here's another tool that I think is quite promising. It's called Monkey Runner. Now, Monkey Runner has nothing to do with Monkey. They just happen to share the same part of the name. Monkey Runner is actually highly scriptable. It's intended for functional testing. So when you're testing functionality of a code, meaning black box testing, right? Like, you know, here's an app, I'm expecting to enter 1, 2, 3, press a button and get the converted rate. I don't care. I don't know the source code. I'm not privy to the internals of the app. I just know what I'm inputting and what I'm supposed to get back, right? It's kind of like your functional testing. So that's what Monkey Runner provides. And so it's a tool that you already have in your toolbox, ships with the SDK. And what this tool does is you need to provide it a script to script the execution, right? So that script is a Python script. And so here's an example of that script. So again, I'm not an expert in Python, but basically this is your standard, you know, import statement. Then you're specifying this is the device. I'm waiting for a connection, so it's going to sit there and wait for a connection to the application. Then it's going to install your application. It's going to specify a package. Okay. Then it's going to say this is the activity that we test. Bam. You can actually start the activity. You can send keys. You can take a snapshot of the application, actual picture. You can save that picture, for example, as a PNG into SD card. So, it's a pretty robust tool. The problem is that not many people know how to use it. So it's just like lots of things in Android. It's a great plumbing, but we need to build things on top of it to make it usable for developers. So there are some tools emerging. Robotium is one of them that's emerging. There's a so it's a black box feature testing framework. There's another one from Pivotal Labs. I forget the name, Electric Sheep or something like that. But there are a couple of tools that are emerging in this space that are basically taking advantage of this plumbing. Okay, so that's about all that I know in terms of the tools that are available today that are already plugged in, available or easily available, free of charge. I don't really know any tool even that costs money that I could point and say, hey, this is a great tool, totally worth it. So we're still kind of in infancy when it comes to that. So that's basically about the testing tools, testing frameworks, and the debugging. So, questions?
Because you can run all these on the live device.
Can you run all these on the live device? Absolutely. So this is everything that I've shown you is agnostic of a type of a device. So it will work over most of them. The common denominator is ADB. So you could run it over emulator, USB, or Wi-Fi connection. So that's basically that. Yeah.
And those are all included in the SDKs from Android?
Those are all included in the SDK, yes. Except Robotium, I mentioned it, but everything else is part of your tool chain. So the debugger, the Logcat, the HierarchyViewer, and the Traceview, they're all there. And then Monkey and Monkey Runner are actually on your device, right? So you run them on the device itself, right? So they're not in SDK, but they're on the box itself. And that's, yeah, those are the tools. And then the Android JUnit test framework is part of the SDK as well. It's a library, right? Because it's part of the Android framework. Yeah. So any other questions on testing, debugging? Questions about automating the tests, fully automating it, from checking out from a repo to running the tests and sending a report somewhere and then tearing everything down. Yeah, so you can do it, you have two ways, right? The first question is black box versus white box. Do you have code or you don't have code? So if you have code, then one access is via the Android JUnit test framework, right? The positives are that the developers themselves can write unit test case. There's schools of thought, the TDD, test-driven development, et cetera, that you should write test cases even before you write any line of code. I think that's fine for Ruby guys, but we're Java people, we don't have to do that, right? So we have the compiler do the work for us. That's my argument to them. But I mean, JUnit test framework is pretty, pretty powerful. It can do a lot of things. The advantage of it is that you can mock the environment pretty well on it. So that's basically what's good about it. The disadvantage is that it's somewhat complex to write test cases, right? So you would do it for certain things, but maybe not just for everything. But it's pretty powerful. So the other one is the Monkey Runner that I was just talking about. And the Monkey Runner uses, as opposed to writing unit test cases with a white box approach, it's using a black box approach, and you're writing a Python script. And the Python script, so first of all, it's good because a lot of QA guys are familiar with Python. It's becoming the de facto standard. But you can do things like Monkey Runner wait for connection, and it's just going to sit there until ADB comes with a device.
Yeah, that's exactly the kind of thing I was.
It's here's automatically installing your package.
Now, if you did do the wait for connection and did you install package that wait, would the install package wait, or would that?
I believe if the install package is going to attempt to install it right away, and it would say no connection, it would die. Yeah. So you can do that. So you specify, you install your package, you launch your package, you get a handle of your activity. Now you can keep doing things to activity. For example, you can start it, right? And you can send keys to your code. So you can pretend like that you're clicking on stuff. You can take a snapshot of the results. You can write it to a file. So that's what the Monkey Runner does. So.
Mine's a service, though. I'm assuming it's the same thing, just without the key presses, right?
Yeah. Yes. You would basically, as opposed to a start activity, you would start a service, and then whichever way you poke your service and test if it's working, right? So that's basically those are two different approaches right now. There are some people. You guys familiar with Selenium? Anybody? So Selenium is a tool that was. Well, are you familiar with LoadRunner? Mercury LoadRunner. That's kind of like the de facto functional testing suite in the industry, purchased by HP recently. So the open source community, people from ThoughtWorks actually, they developed an open source alternative to Mercury LoadRunner. They called it Selenium. Any clues why? So Mercury is a poison, and Selenium is the antidote, which is a perfect name for an open source project. So basically, they created Selenium as an alternative to Mercury, and it's actually a pretty powerful tool for testing web applications. Like, if I have a complex web application, like say I'm, doing a shopping cart and I'm going through a product list and picking a product, putting it in a shopping cart, checking out, making sure taxes, everything's calculated properly, blah, blah, blah. Well, you can script all that. You can just basically say record, and you're like doing this as a human, right? And then you say stop recording, and you say I'm expecting the following things to have happened, right? And then you can keep running this over and over and over again automatically, right? So that's what Selenium does. And there's something called the Selenium driver, and you can implement it either in Java or Ruby. So you have choices. There's been a lot of discussion about providing this similar tool for Android. There was a project on, I believe, a Google code called Positron. But I've been tracking that project for a while, and it seems like it's kind of dying off right now. So I don't really know what's going on with that. The guys from Sauce Labs, which is one of the companies behind Selenium, I saw an interview with their CTO, and so these guys are all about automated testing, and they understand that pretty well, at least in the web world. So I saw the interview with the CTO, and just for fun, as a fun project, he was curious about how to test the mobile apps, right? So yes, automating all this stuff, that's kind of cool. But in mobile apps, you have things like swipes and this and that, right? So he wanted to write an automated test case for Angry Birds, right? How do you test Angry Birds, right? Like, you have to take that, bird and do the finger movement and so on. So he ended up, just for fun, building this whole device out of like Legos and things like that would basically, you would put the phone and you would script it, and there would be like a little hand and like throw the bird and so on. And it's kind of, it looks interesting, and it's all fun and games, but that kind of thing could also emerge in the future. Ultimately, you got to test on multiple devices. This is just testing kind of the code base and all that, but we have friends at, for example, Square, the mobile payment company, and they are probably leading the pack when it comes to UX, UI type of efforts, and they basically have a room with like gazillion devices, right? And they just sit there and run their apps one by one and make sure that it works. So gamers do the same thing. So that's kind of setting the standard for the UX and all that. Thank you guys, appreciate it.